So we looked at the sine rule and the cosine rule in the previous videos, and the last equation that we do is find the area of a triangle. And so we know how to find the area of a normal triangle, which is base times height divided by 2, right? But if the angles at a weird, or they're at weird angles like this, then the general equation is half AB sine C. So this equation works for any triangle, to be isosceles or equilateral or rectangle. Right, so same notation as before. If we have A, B, C as the lengths, then we're going to have the opposite sides as the angles capital A, capital B, and capital C. So for this equation to work, you need to know the lengths and then the angle in between. So similar to the cosine rule, right? You need to know the lengths either side and the angle in between, and then you can just plug this equation in, or the numbers in, and find the area of the triangle. So that's all the equations you really need to know for a triangle. And so in some test exam questions, they might give you just a combination of, or you might have to use a combination of these rules just to find out the final answer. Okay, so let's take a look at this example here. So we're asked to find this angle x. And so we're probably going to have to use a combination of all these rules that we've learned up to now. So first things first, you just have to identify what pairs of angles and lengths we know. Well, we know this length here, the total length here, and the pair of that length is the one opposite, this one here, right? Which is made up of x and this extra angle. But luckily we know there's 50 degrees, and because the line is 180, then we know this angle is going to be 130 degrees, like so. Okay? Right, what the lengths do we know? Well, we know this length here. That means we need to know this angle, which we don't know, right? The angle ABC. So we'll probably have to find that angle first using the sine rule. Okay? So I'm going to use sine, and let's call the angle ABC over the length would be 3.8. is equal to sine 130 divided by the total length, which is 2.4 plus 8.6, so 911. Okay, so sine ABC is equal to 3.8 sine 130 degrees over 11, and if you work this out, ABC comes out to be 15.3 degrees. Okay, so we found another angle. So this angle here is 15.3 degrees, which means that if this angle is 130 degrees, then we can work out this angle, right? So the angle DAC. The DAC is equal to 180 minus 130 minus 15.3, which gives you 34.7 degrees. So we're finding more angles. Okay. Now we're trying to find this x, right? So to find the x, what else do we need? Well, we do know this length here, okay, and we know this angle here. And so ideally, and we know this length here, right? So therefore, we can actually find this length as well, right? The length DC, which could be used later on. So what rule do we have to find to find DC? Well, it's going to be the cosine rule, right? So we're going to say DC squared is equal to 2.4 squared plus 3.8 squared minus 2 times 2.4 times 3.8 cosine the angle DAB, which we found. The DAC, which we found as 34.7, sorry. And so if we work this out, DC comes up to be 2.28 centimeters. Okay, so now if we get rid of some of these values, then we know this length here, we know this length, we know this length. So if we know three lengths and we're trying to find the angle, then we can use the cosine rule, but we have rearranged to find the angle, right? So therefore we'll have cos x is equal to 2.28 squared plus 3.8 squared minus 2.4 squared over 2 times 2.28 times 3.8. And if you work this out, cos, what x will turn out to be 36.9 degrees. So you can see that we've used a number of different rules in various ways just to go step by step so we know some lengths in order to find other lengths and other angles. So it's your job just to identify which rules or which angles or lengths we need to find in order to find the final answer, and therefore which rules we need to be using. Okay, so let's try one final example. So in the triangle ABC, AB is 14, BC is 12, and CA is 15. So if we were to draw it, we'll have ABC. AB is 14, BC is 12, and CA is 15. Find the sides of the angle C, so this angle here. Okay, so we know three lengths, we're trying to find angles, so cosine rule. So cos C is equal to 12 squared plus 15 squared minus 2 times 12, so minus 14 squared all over 2 times 12 times 15. And C comes out to be 61.3 degrees. Right, in part B, they ask us to find the area of triangle ABC. So the area, right? So area is equal to half AB sine C. But remember, the lengths have to be either side of an angle, okay? So if we know this angle C here, then the lengths we're going to be using is this 12 and 15, not the 14 here, okay? So it's going to be half times 12 times 15 sine 61.3 degrees, which comes out to be 78.9 centimeters squared. Okay? So as we said, I just identified the right lengths and to use in my equation, and then I found the answer. So these triangle rules, they do get a bit more complicated as you go along. So maybe go back into your textbook or look at some past paper questions just to practice some more difficult triangle geometrical questions.